Okay, continuing on our journey into the world of logarithms and into the wonderful brain of John Napier, who here he is right in the background. We're going to start working with some more logarithmic relationships. And remember, logs mean exponents. They mean the exponents of some base. So if you can remember, log means exponent. You're going to be all right in this chapter. Okay, so right here, example 1. Evaluate this question. All right, log means exponent. So this is saying the exponent of 2 that gets me 2 to the third. The exponent of 2 that gets me 2 to the third. Is it as easy as it sounds? Yes. So the exponent of 2 that gets me 2 to the third, I guess that question mark has to be 3. Okay, so example 2. There are 2 ways to do this, and whichever way you like, cling on to. We could start with just looking at it straight up. What is the exponent of 3 that gets me 81? Okay, 4. Plus, what is the exponent of 3 that gets me 3? 1. Okay, so 4 plus 1 is 5. Or we could look at it another way. We could realize that when we're adding, let me erase this right here. If we want to turn this back into a real world problem, I'd look at it this way. If we're adding right here, that meant John Napier was doing this. He was working in base 3, but remember, add means multiply. So we're going to take 81 and we're going to multiply it by 3. And I can do this because my bases are the same. And as long as my bases are the same, life is good. So when I figure that out, I get log 3 243. Now this is asking me, what is the exponent of 3 that gets me 243? 3 to what power gets me 243? That's right, 5. Remember, we could also roll the log. We could put an equals x there, and then we can say 3 to what power gets me 243. So you've got to decide which way you like. Gave you a little tricky one here. Well, I'm going to come over here and I'm going to do way 2 first. I'm going to realize that this is adding. So that meant the number 9 plus 6, 16, was really times. So that is 54, carry the 5, 144. So this is saying the log of base 12 that gets me 144. So what is the exponent of 12? So 12 is my base. What is my exponent that gets me 144? All right, that wasn't that bad. That's 2. But look if you did this on way 1. What if you did not change it back into a real world problem? What if you kept it like this? What is the exponent of 12 that gets you 9? Ooh, so 12 to what power gets me 9? That's kind of creepy. Let me see if I can think that through. Well, there can't take the square root of 12, can't take the cube root of 12. All right, so I really can't think of any answer here. So in this case, way 1 is out. All right, way 1, way 2. Well, I'm going to stick to way 2 for a second. This is asking me to subtract exponents. All right, but I don't want to deal with the exponents. We found out in the last problem that dealing with the exponents can be a pain in the butt. So let's change this back into a real world problem. Okay, so if I'm subtracting numbers, that meant in Napier was trying to get people to divide numbers. So 64 divided by 16. So let's clean this up. Log 4, 64 divided by 16 is 4. Oh, this is not bad. My base is 4. My exponent is x. And my power is 4. So 4 to what power gets me 4? Oh, we like this one. X is 1. Let's see if we get the same answer on the other side. All right, I come over here, and this says, what is the exponent of 4 that gets me 64? Oh, that's easy. 3. Minus. What is the exponent of 4 that gets me 16? 2. 3 minus 2 equals 1. So basically what I do is I see if way 1 works quickly, and then if it doesn't, I go to way 2. Okay, last problem. I think it's problem number 5. If the exponent of 10 is x, and that gets me 3, and the exponent of 10 is y, that gets me 5, express log 10 radical 3 over 5 squared in terms of x and y. Oh my goodness, what is this saying? All right, so I'm going to take this and I'm just going to rewrite some key information. I know that every time I see the log of base 10, that gets me 3, I can replace it with an x. And I know every time I see log base 10 of 5, I can replace it with a y. And if I'm looking at this problem, looky, I got a 5 in there, I got a 3 in there, and I got a base 10 in there. Somehow, I got to get those into play. All right, so what we do right here is we start rewriting this as John Napier would write it. Okay, we have log and 10. We have radical 3, which Napier says we can write as 3 to the 1/2 power. We have this division sign, which we know really means subtract. And then we have the second part, which is the log of 10, 5 squared. Now we still have to rewrite that because John Napier doesn't allow us to have exponents. And exponents fall down in front. So when I write this, it's 1/2 log base 10, 3 minus 2, this exponent falls down in front, log base 10, 5. Now, you're done. If you don't see it, it's right here. Remember, every time I see the log of 3 in base 10, I may replace it with an x. Look, I have the log of 3 in base 10. I can replace that with an x. And look what I can replace that with. A y. So there you have it. You did this in terms of x and y. Here's your x and here's your y. Done.